In this video, we are going to learn about the critical angle and the total internal reflection. This is our video number 3 on the chapter light. Before this topic, we have already done the reflection by mirror and the refraction or the bending of light. So let's get started with this topic. Very relevant and very important topic. After going through this video, you'll understand every fine details about critical angle and why and how the total internal reflection happens. So very important to understand before we begin here, how is the light traveling? Look at the arrows on the light. The light is coming from the glass and moving in the air. This is the most important point of thing to understand when we are talking about total internal reflection and critical angle. The light is traveling from a dense to a less dense medium. Pay attention to this. Dense to a less dense medium. It is moving from the glass into the air. The incident ray is in the glass and it is moving out in the air. So if the light is traveling from a dense to a less dense medium, they are refracted away from the normal. So this is what you already know. When the light comes from a high density to a low density medium, it bends away from the normal. But what if you increase the angle of incidence here? As the angle of incidence is increased, so does the angle of refraction. Let us see it on a whiteboard to understand what we are talking here. So I am taking this whole screen on my whiteboard and we are going to understand the second point. As the angle of incidence is increased, so I am going to increase the angle of incidence. I am making another incident ray which is at a higher angle of incidence. If you see, the angle of incidence has increased, right? What happens as a result to the angle of refraction? The angle of refraction also increases. The angle of refraction has also increased. It has increased. If you increase the angle of incidence further, imagine that you are doing it. You're increasing the angle of incidence further, the angle of refraction also increases. As and when you keep increasing the angle of incidence, you keep increasing the angle of incidence, the angle of refraction also keeps increasing. Right? I hope you understand. Angle of incidence is increased slowly and steadily. You are making the incident ray go this side further away from the normal. Angle of incidence is increased. Angle of refraction is increased even more. So that's what these 2 points says. If the ray of light are traveling from dense to a less dense medium, we know that they are refracted away from the normal. But if the angle of incidence is increased, so does the angle of refraction. Angle of refraction will keep increasing and increasing, and then suddenly something strange happens. What happens? When the angle of incidence of the light ray reaches a critical angle. So we have increased the angle of incidence so much, you arrive at an angle which you call as the critical angle when the refracted ray is emerging at an angle of refraction of 90 degrees. This angle is called a critical angle. The angle of incidence at which the refracted ray or the refracted angle becomes 90 degrees is called your critical angle. So let's come back to our whiteboard. You have ultimately increased your angle of incidence to such an angle that the refracted ray is at 90 degrees. This is your refracted ray. So let us understand. You have increased your angle of incidence to this particular angle. so that the angle of refraction here becomes a complete 90 degrees. This angle of incidence, the angle of incidence for which R is equal to 90 degrees is called critical angle. Critical angle. What happens next? You can still increase the angle of incidence. What if you still increase the angle of incidence? What do you think will happen? Let us come back to the screen and understand. Here, if you see, some data is given. For the glass, the critical angle is 42 degrees. 42 degrees is the critical angle for glass. For water, the critical angle will be something else. For oil, it will be something else. Different materials, they have different critical angle. On the screen, the critical angle value for glass is given. Do not get confused that 42 degrees is the critical angle for every substance. No, it is the critical angle only for glass. Right? So let us see what happens when the angle of incidence becomes greater than the critical angle. Now, even if you increase the angle of incidence slightest beyond the critical angle, no refraction happens. No refraction happens. As soon as the angle of incidence becomes more than critical angle, reflection starts happening. Reflection starts taking place. If you see your angle of incidence, no refracted ray anywhere outside in the air, there is no refracted ray, the ray gets reflected totally. This is called total internal reflection. So let us read what is written here. When the angle of incidence of the light ray is greater than the critical angle, no refraction takes place. No refraction takes place. Instead, all the light is reflected back. Into where? Into the denser medium, and in this case the denser medium is your glass. This is called your total internal reflection. So when does the total internal reflection happen? When the angle of incidence becomes greater than the critical angle. So when I is more than critical angle, what happens? Total internal reflection. Reflection. So very important, no refraction, only reflection takes place. When I is equal to critical angle, then what happens? Then R is equal to 90 degrees, angle of refraction becomes 90 degrees. When I is less than critical angle, then what happens? Refraction happens. So these are the things that you need to take care of, right? So these are some notes that you can write down. When the angle of incidence is less than the critical angle, normal refraction takes place. When the angle of incidence becomes equal to critical angle, the angle of refraction becomes 90 degrees. When the angle of incidence is more than the critical angle, total internal reflection takes place. This is your understanding and theory about critical angle and total internal reflection. So please do remember, in order for total internal reflection to take place, the rays of light must travel from denser medium to a less dense medium. Very important point to understand. If you want the total internal reflection to take place, the light has to travel from high density to low density, not low density to high density. It will never take place. High density to low density medium. And second point, the angle of incidence must be greater than the critical angle. The angle of incidence must be greater than the critical angle. Now, deriving the relationship between C and N. C is your critical angle and N is your refractive index. So let us derive a relationship between these two quantities. Because the ray travels from glass to air, so we are talking about a scenario. So let us draw a scenario that the light is moving from the glass. This is your glass, and it is moving in the air, right? Because the light is moving from the glass to air at point P, so this point is point P, sin I over sin R will be equal to, where is the incident ray? Incident ray is in the glass. Incident ray is in the glass. So this whole equation becomes equal to speed of the light in the transparent medium over the speed of the light in the air. This comes from your law of refraction. Sin I over sin R, because the incident ray is in the glass, so therefore in the numerator it is the speed of the light in the glass over the speed of the light in the air, because it is emerging in the air. So refracted ray is in the air, so sin R corresponds to speed of light in air. And if you look at this equation, how do you define N? How do you define N? N is, let me make some space here. What is the formula for N? Say that you have to find the refractive index of any substance. So speed in air over the speed in the substance, right? So what should this ratio should be equal to here? 1 over N. Compare these two sides, left hand side and right hand side. Speed of the light in air, so 1 over N is how much? Speed in substance over the speed in air. And this is precisely what you have here, speed of the light in the substance over the speed of the light in air. So they both are equal. If you have questions, type in the comment box and let me know. N is defined as speed of the light in air divided by the speed of the light in the substance, right? So therefore this whole left hand side should be equal to 1 over N. But at critical angle, what happens at the critical angle? Angle of incidence is equal to the critical angle and the angle of refraction is 90 degrees. So what happens at the critical angle? I becomes C and R becomes 90 degrees. So let us substitute these values. Let us substitute these values in this equation. Substitute these values. So what do you get? Sin C over sin 90 is equal to 1 over N. Alright, simple and easy so far. And sin 90 we know is 1. So from this equation that you see here, sin C is 1 over N. Sine of critical angle is equal to the reciprocal of refractive index of the substance, or you can say that the refractive index of the substance is equal to the reciprocal of the critical angle of the substance. This equation you need to remember. Important and relevant equation, and the derivation of it you can go through it again, go through this section of the video again to understand it properly.